take a minute and write down what an indefinite integral, the indefinite integral of f of x dx means. Then take a minute to write down what the definite integral from a to b of f of x dx means. Don't look it up. You should know this now. So write down what you think they mean. Okay, did you write that the indefinite integral of f of x dx means the most general antiderivative of f of x? And by most general, we mean you've got a constant plus c. So, for example, the indefinite integral of x squared dx is x cubed over 3 plus c, because the derivative with respect to x of x cubed over 3 plus c is x squared. An indefinite integral is not just a function, it's a family of functions because of the plus c. Did you write down that a definite integral means the limit of a sum? The limit as n approaches infinity, the sum as I goes from 1 to n of f of x sub I star delta x. Remember in 2 lessons ago, you evaluated a definite integral. You really evaluated the definite integral from 0 to 2 of x squared dx by using this 4-step process that's embedded in this limit of a sum definition, partitioning the interval AB into n equal subintervals, picking a number in x sub I star in each subinterval, forming a rectangle over each subinterval and using f of x sub I star as the height of that rectangle. You know, you can make x sub I star be left-hand endpoints, right-hand endpoints, midpoints, forming a sum of the areas of the n rectangles, and then taking the limit as n approaches infinity of that sum. That's what we mean by a definite integral. It's the limit of a sum. And remember, that gives this symbol, that gives this integral symbol meaning. This integral symbol from A to B should conjure up in your mind limit of a sum. Kind of looks like a stylized L or a stylized S. This symbol means limit of a sum. So when you think of a definite integral, you should think of that long homework problem you put in Dropbox. That was the 4-step process that was evaluating the integral from 0 to 2 of x squared dx. At that time, when you put that in the Dropbox, you didn't know that was called a definite integral, but that's what you were doing. I believe we got as our answer for this 8/3, didn't we? And that gave us what? That gave us the area underneath the graph of y equal x squared from 0 to 2. And that area was 8/3. So the point is, an indefinite integral and a definite integral mean very different things. But there's got to be a connection, right? Otherwise, you wouldn't call them both integrals. You wouldn't use the same notation for them. Here's the connection. The fundamental theorem of calculus. It says the shortcut for evaluating a definite integral from f of x dx from a to b is the indefinite integral evaluated at x equal b minus the indefinite integral evaluated at x equal a. This symbolism right here just says, okay, you take the indefinite integral, the most general antiderivative, you plug in b. You take the most general antiderivative, you plug in a, then you subtract. So for example, here's the shortcut. The definite integral from 0 to x squared dx, what's an antiderivative of x squared? It's x cubed over 3. We evaluate that at x equal 2. We evaluate that at x equals 0. And we get 8/3 minus 0/3 is 8/3. So the reason we use this symbol for an indefinite integral is that we have borrowed it from the definite integral. This symbol should have meaning to you for the definite integral. It should make you think of a limit of a sum. But we just borrowed it for the indefinite integral because of this shortcut called fundamental theorem of calculus. That tells us that instead of going through the limit of a sum process, that long, arduous process for finding the value of a definite integral, we can just evaluate the indefinite integral at the endpoints and subtract.